No! I'm back. All right, today, Standard Deviation Part 3, we're going to look at Anthony Rizzo's home run totals from the last 8 seasons. His first season in the league, he only had like 100-some at-bats, only hit 1 home run. So we're just going to throw that one out, and we're just going to look at these 8 data points, okay? So write this down on a piece of paper and follow along with me so you can understand standard deviation just a little bit better. But first of all, is this even the right numbers we should look at? He hit 15 home runs this season, 23, 32, 31, 32, and so on. Is that even appropriate to like measure against themselves? Because what's the variable we're not looking at? Games played, at-bats in the season, right? So I don't think you should use this. In your Desmos from yesterday, I asked a question about coronavirus cases per state. Is that the right number we should be looking at? And that was the last question to analyze that. I said, probably not, because some states have more people than others. So just because you have a higher number of cases, does that mean that you're worse off? Well, I mean, all the cases are bad, but still, like, let's analyze it per capita, per person in that state. Same thing here, okay? So we're gonna change the data. Ta-da! So now we have his at-bats, total plate appearances, actually, every time he comes to the plate, divided by his home runs. And these are the numbers that we have here. The other ones are kind of misleading, okay? But if you look at this number used to be a 15, and this was a 32, but you can see now they're more close to each other because we're using a better metric to determine how many home runs he's hitting per plate appearance, or plate appearances divided by home runs, okay? So we need to order these from least to greatest. Least to greatest. We're doing that so we can actually do, the median here, the IQR, the stuff we looked at yesterday. The mean, we're just gonna have to calculate by hand. Or, remember, there's a standard deviation calculator that you can get on the intranet. So how about you click on that from the website and type in these 8 numbers. I'll do it too. Go. The median doesn't show up on there, so we're just going to have to do that real quick ourselves. Well, here we've got 1, 2, 3, 4, so it'd be in between. Oh no! Watch out! Nope. 1, 2, 3, 4. It'd be in between those two guys, so it's 22.65. In between 60 and 70 is 65. So we got 22.65 for the median. The mode is the one that occurs most frequently, but here we did have that before with the 32s. There were actually 3 times in a season he hit 32 home runs, and that would have been nice for the mode, but we don't have any that are exactly the same here, so there is no mode. All right, interquartile range. Well, we've got 4 numbers in the first half, so we're going to split right here, and that's going to be our Q1. So in between 21.1 and 21.6, I think we have 21.35, okay? And that's Q1. And then over here, in between 24.5 and 26.6 is 25.55. And that's Q3. Whoop. So the interquartile range would be the subtraction of Q3 minus Q1. So we got 25.55 hundredths minus 21 and 35 hundredths for an IQR of, looks like 4.2. Now I just did all that in the brain space, so let me go ahead and check that real quick and make sure it's right. Brain, good today. Now for standard deviation, we had 5 things we have to do to get the standard deviation. Number 1 is calculate the mean. Done. 23.55. Number 2, we have to subtract each of our data points from the mean. Standard deviation calculator does that for us, so we'll just refer to the calculator here. Then we take all of those differences and we square them, also done on the standard deviation calculator. Boom. Then we average those. Now this, is it an entire population or is it a sample? I said I lopped off 1 year, which I still think is okay to just get rid of because he only had like 100 at-bats. So I'm going to say that this is his entire career, so it's an entire population. So you're going to divide by 8, okay? The sum of the square differences is 81.3. And you're dividing by 8. So jot that down, okay? And that would get us to the variance. And the variance is 10.16. And how do we go from variance to standard deviation? Well, that's the definition we wrote down 2 days ago. And we talked about yesterday, it's the square root of the variance. Since you squared everything, now we square root it, get to be back to where we were. So the standard deviation is 3.18, let's say 3.2. Not a very good approximation symbol. I'll try that again. Okay. We have Anthony Rizzo's standard deviation. What this will do for us is help to determine how consistent he is. That's one of the things I love about this guy. He is very consistent. Year in, year out, he always hits about the same number of home runs, drives in runs. He does everything that you'd want a baseball player to do on the field. Great defender, wins Gold Glove. So, like, he's just remarkably consistent. Does this metric prove that? Does this show that he's also very consistent numbers-wise? Because I just think he is. So let's take a look over there and see if it's true. I need you to do this. Oh. Hold on. Dude. I got it. I'll do it. Calm. Okay, let's take the mean and put it in its spot, which is right here. 23.6, around it to the nearest tenth, it was 23.55. Now we're going to add the standard deviation several times to get 1, 2, and 3 sigma away from the mean. So we're adding 3.2 every time. So this plus 3.2 is 26.8, plus another 3.2 is 30, and then plus another 3.2 puts you at 33.2. To go this direction, you simply subtract the standard deviation. So minus 3.2, or 20.4, minus 3.2, 17.2, and then one more time, put you back at 14. Okay. Now let's take each of the data points and put them in their locations underneath the bell-shaped curve. 19.3 would be right here. And then we've got 21.1, which would be here. Coming next, we have 21.6, also in that spot. And we've got a 22.6. See how it's shaping out right now. 22.7. 24.5, jump on the other side of the mean for that one. 26.6. And we have a 30, which is just sitting right here, right on 2 sigma. Anthony Rizzo is a very consistent home run hitter, RBI producer, you name it, he is a model of consistency. We've got 1, 2, 3, 4, 5, 6 of his data points. 6 of the 8, or 75%, are within 1 standard deviation. We have 1 that is outside of that, but squarely in the middle between 1 and 2. And then this season here was his second in the league, his first full season in the majors, and he was adjusting, so he didn't hit as many home runs per at-bats. The higher the number, the less the home runs you hit that season. Okay, that's how this one works. So this was his most prolific, this was his worst, but as you can see, he's centered right in here, very consistent player. Okay? So that's just one way that you can look at this. There's many ways, many things you can do with the data set outside of mean, median, mode, IQR, standard deviation, in order to analyze. But you want to be using good metrics, good numbers, not just maybe total home runs, but at-bats per home run. Maybe not just total number of coronavirus cases, but how about per person or per capita in the state? So take the number of people, divide by the number of cases, and look at that number instead of just a holistic number that encompasses everything. Okay? So let's be smart about our data. All right. We're going to do some more stuff, I'm sure, in the lesson, but for right now, it's time for the marker toss, baby. Watch out, Elise! I hit her in the head, and it still went in. It still went in. Wednesday.